of a function ft, of a continuous function ft is defined as ft power minus st dt 0 to infinity. The inverse Laplace transform is defined by L inverse Fs equal to ft equal to 1 by 2 pi j sigma minus j infinity to sigma plus j infinity Fs e to the power ts ds. We didn't see the inverse Laplace transform equation earlier, but note that this is the inverse Laplace transform equation. L inverse Fs equal to 1 by 2 pi j integration sigma minus j infinity sigma plus j infinity Fs e to the power ts ds. So can you find the inverse Laplace transform of 1 by s using this equation? Find the inverse Laplace transform of 1 by s using this equation. Done? Anybody could do it? Yes? Could anybody do it?
So it will be 1, sir.
It will be 1, right? Okay. So next we will be saying, next is, so we don't use equation B as we know. Now Laplace transform of a unit step function. Unit step function is 1 by s, right? We did it last class, right? Okay.
Yes, sir.
And Laplace transform of unit impulse function also we did, which is equal to 0, which is equal to 1, right?
Yes, sir.
Okay, find the inverse Laplace transform of find the inverse Laplace transform of 1. Can you find it? Oh, forget it, forget it. Now now solve this equation. Integration t1 to tt ft delta t minus t0 dt equal to ft. T1 is less than T0 is less than T2 and equal to 0 if T0 is less than T1 and T0 is greater than T2. You can prove it, right? Yes? Because delta T is equal to 1 only when T equal to T0 and it is 0 otherwise. So what will happen is it will be if T0 if T is within T1 and T2 and it will be 0 otherwise. Fine. Understood?
Yes.
Yes, sir.
Okay.
Yes, sir.
Now Laplace transform of delta t is equal to 1, we have seen last class. Now the above statements that f and fs are transform pairs. What it means is that for each ft there is a unique fs And for each fs there is a unique ft. We can remember that pair relationship between approximately 10 and we replace the pairs, we can go long way. Okay, transform pairs. E to the power minus 80 ut is equal to 1 by s plus 1. We did it, right? We solved it last class. Okay, e to the power tut equal to 1 by s square. We did it last class. If you have any questions, you can ask. How can you solve this problem? Using integration by parts, right?
Yes, sir.
So integration by parts, if you use, then you can solve this problem. Okay. Cos omega t equal to s by s square plus omega square. Cos omega t ut equal to s by s square plus omega square. ft minus a ut minus a is equal to e to the power minus as fs. Can you prove this? Prove this. Done? If anybody has any questions, you can ask, or I am asking you to solve these problems. This will be helpful for your exam. The simple integrations, nothing more than that. Anybody done?
Sir, doing sir.
Do it fast. Done? Just replace t minus a by x. That's all.
Sir.
Done?
Yes,
Yes,
sir.
sir. Yes, sir.
Okay. Frequency shift. This you can prove. This is very simple. Laplace transform of e to the power minus at ft is equal to f of s plus a, capital F of s plus a. Do you need to prove it or you can understand this? Can you understand this?
Yes, sir.
Yes.
Okay.
Yes, sir.
Okay. Frequency shift. Can you find Laplace transform of e to the power minus at cos omega t without using the integration? Yes? Can you solve it without using integration? What is Laplace
Yes.
transform of cos omega t?
Uh, S
by
by
s
S
square
square plus omega square.
s upon s
So,
square.
so e to the power minus 80 cos omega t is?
Sir, that will
S
be
plus
S
t.
plus, just S
S
will
plus
be
s.
converted to S plus A.
That's right. That's right. Okay. Now, time integration, if you Laplace transform of integral of ft between 0 and infinity is equal to what? Time integration of ft between 0 and infinity is equal to what? Done? Anybody done?
So done, sir.
What is it? What is the solution? What is the solution? One by SFS? Yes?
Yes, sir.
Okay, okay. Okay. Now, differentiation with respect to differentiation, similarly, you can prove it is SFS minus F0. If it is double differentiation, then S square Fs minus F0, SF0 minus minus F double dash 0, Fs0, F dash 0. We can extend it so that Laplace transform of dn dtn dnf dtn is equal to s to the power n fs minus s to the power n minus 1 f0 minus s to the power n minus 2 f dash 0 up to f of n minus 1 0. So we have seen that the unit impulse functions Fourier transform is 1, unit functions Fourier transform is 1 by s, e to the power minus st Fourier transform is 1 by s plus a, to the power minus 80 actually. T's Fourier transform is 1 by s square. T to the power n's Fourier transform is n factorial by s to the power n plus 1. T e to the power a minus e to the power 80's Fourier transform is 1 by s plus 1 t. T to the power n e to the power minus 80's transform is this. Sin omega t omega by s square plus omega square cos omega t s by s square plus omega square. And if you replace it by e to the power minus 80 sin omega t, then the s will be replaced by s plus 1. What about this? Sin omega t plus theta? Find the Laplace transform of sin omega t plus theta. Done? Anybody done?
Yes, sir.
What is the solution?
So first we have to do trigonometrical transformation and then we have to do Laplace transform.
So what is the solution?
So sin of omega t plus theta we can write as sin omega t cos theta plus cos omega t sin theta. We have to apply Laplace transform of these formulas, sir.
That's right. That's right. Okay. Now we know that time shifting property is e to the power t minus t0 e t minus 0 equal to e to the power minus t fs ft ut minus 0 equal to e to the power minus t0s L Laplace transform of ft plus t0 and so on. Integration is 1 by s fs. Okay. Now solve this. Inverse of s into s plus 1 by s plus 3 into s square plus 66 plus 18. Not using MATLAB, you have to solve it using your pencil and paper. Fs is this, you have to find the inverse Laplace transform. So note that you can write s square plus 6s plus 18 is equal to s plus 3's whole square plus 9, right?
Yes, sir.
And s plus 6 equal to s plus 3 plus 3. Now replace s plus 3 by something, let's say p, and then solve it. So it is s into p plus 3 divided by p into p square plus 9, p square plus 3 square. Anybody could solve it?
Yes, sir.
What is the solution?
Sir, 2 e to the power minus 3t into cos 3t minus e to the power minus 3t.
Right. Others got it. You can say you have to simply then you have to do a what they call a fractional, the what is called, it is fractional what? repeated fraction, iterated fraction. Okay. Initial value theorem, I'm not going. Final value theorem, you know. All of this you know. Okay, finally, I want you to solve this. So, let's go to the initial value theorem. Initial value theorem says limit SFS S tends to infinity equal to limit T tends to infinity FT equal to F0. Do you agree with this? Yes? Do you agree with this? Anybody? What is FT? Look at the definition of FT, small ft. Small ft equal to integration 1 by 2 pi j integration sigma plus sigma minus j infinity, sigma plus j infinity, then fs e to the power s omega d omega. So from there you can find it. Okay, finally I want you to find the solution or find the convolution theorem. Convolution theorem is what? What is convolution theorem? Anybody knows convolution theorem? Anybody? I taught it last class. What is Fs into Gs? Capital Fs into capital Gs equal to what? Integration 0 to infinity ft, f tau gt minus tau d tau. If you take the Laplace transform of this function, then it is called the convolution theorem. So I'll show you convolution theorem. Just wait. I'm not finding the this convolution theorem. What is the convolution theorem? Can anybody tell me? What is the convolution theorem? Yes?
So basically, if there are two functions, and if we are making a Laplace transform of the convolution, it's the same as taking the Laplace of the two functions separately and then multiplying them together.
Yes, but what is the function? What is the two functions, ft and gt? And what is the convolution then? Integration 0 to t.
Laplace transform of ft into Laplace transform of gt.
Yes, what is the value? What is the inverse value? I covered in last class.
So, sir, like integration of t to 0 fu into gt minus u du.
Right. Integration of t to 0 to t fu g t minus u du. Okay, this is called the convolution theorem. Remember this is very important. Okay, so we've come to the end of the Laplace transform. I will not share this slide. These slides are available already to you. You follow the slides of Laplace transform yourself. Now, what I want to say is, so your first continuous assessment is on 22nd week, the week on the 22nd of February. So I will set the questions in Moodle, I think. Have you logged into Moodle? Yes.
Yes, sir, but we are not logged into any signals and systems class, sir.
Okay, signal system. Then maybe I will talk with the Professor Debasis Nandi and I will tell you. But what I want to say is that that day your syllabus on this part will be first of all signals and system introduction. The introduction part that is covered even function, odd function, unit function, impulse function, and all those things. That is the first slide that is shared. And second is Laplace transform. These two chapters will be there in the syllabus. And the exam will be on the 22nd week of February, 22nd February week. And the next announcement is that I'm not taking tomorrow's class, and there will be no class for this slot of my class for next 2 weeks. I'll take next class on 3rd of March. Okay? Understood?
Okay, sir. Okay, sir.
Okay. So next class is on 3rd of March. I will take, and your exam is on the week of 22nd February. That time you have to take the syllabus from this part is the first chapter, Introduction to System Signals and Systems, and the second chapter, Laplace Transform. Fine? Okay, I'll leave now. Do you have any questions? If anybody has any questions, you can ask.
Sir, could we get the slides for this part also, sir? Because actually, I know we have the Laplace transform parts, sir, but over here there are a few more standard results that are probably not there in those notes, sir. If you could share.
I'll share.
Thank you, sir. Thank you, sir.
So next class is on 3rd of March. Okay. Thank
Okay, sir.
you. I'm leaving.
Thank you, sir. Thank you, sir.
Okay.
Okay, sir.